Okay, so for this question, let's see, what do they want us to do? So I've got the derivative, I've got the function. They want me to write the population when x equals 6. So what I'm basically doing, I'm trying to write a point 6, comma, some value. Okay, so I'm going to do 99.4 times 0.96 to the 6th power. So we'll evaluate that. Let's see. So 99.4 times 0.96. Now we know this is the decay equation, don't we? Raised to the 6th power. So 77.8. I mean, for us, it's 77, 78 would be great. For my open math, we probably want to not do too much rounding yet. So I'm going to store that in this calculator just so I don't lose it. Whoops, no, a second, quit. I'm going to store this in alpha A. All right, so I've got that stored. So the first answer would be 70. So let's come back here to my open math. Let's see where I want to go here. I think it's, I'm going to say 1,000 people. This is in thousands. Okay, round to 3 decimal places. Let's see what my open math wants. I would say 77.806. Is that, what do they say? Oh, see, they want more. Yeah, I don't know. You've been doing math for a while now. I always find that I go until I don't have to round. 3 decimal places would do that. 77.806 because of the 1, right? What's the rate of change? Well, now they're asking me for the derivative, right? So that's one reason why I want to make this video for you. Let me come back to my my smart board here. This board. Let's see here. So what I would do is, what you got to do is, so we're going to do the derivative of this function here. I'm going to go. Let me go to the Paint app. So I've got 99.4 times 0.96 to the x power. So this is an exponential function. And what you got to remember is, if I'm trying to take the derivative of an exponential, the derivative of a to the u, it's going to be a to the u times the derivative of the u with respect to x times the natural log of the base. Okay, so for this one, and of course, then 99.4 is just a multiple, right? So a constant. So we can just bring that along for the ride. So 99.4 times 0.96 to the x, and then the derivative of x is 1, but then we're going to do the natural log of 0.96 to get the answer. So that's what the derivative is. They're asking me to find that slope at that point. So we're going to evaluate our function now. We're going to evaluate that at 6. So let's see. Let's come back here to, let's see if I can get my calculator here. And let's minimize that. Actually, I don't need to. I think I can just do it right here. So 99.4, 99.4 times 0.96 raised to the, was it 4 or no, I don't remember. Oh no, 6. At least they're being consistent. So raised to the 6th. And then I got to remember to multiply by the natural log of the base. If somebody's going to get this wrong, that's usually what they miss. Because e to the x, the derivative of e to the x, to the x. So that's my rate of change. So that's my slope. So now what I've got going on here, well, let's go back and I'm curious. Let's see what my math says. Yep, good. See, that agrees. Now for the linearization, this is where you got to remember, we're going to say, okay, we're finding that the equation of the tangent line at x equals 6. So I've got, and remember, I always just think of this as the point slope form. So y minus y1 equals the slope times x minus x1. And in calculus, we talk about L of x minus f of a equals f prime of a times x minus a. See how it's the same math. We're just doing a little bit different notation. And I know I've got this 0.677.806. And then I know I've got the derivative. The slope is equal to this negative 0.3176. Now, typically what my open math will accept is I don't have to write it in slope. Well, it won't let me write it in slope intercept or point slope form because they have the L of x. So I can just, what I'll do often is I'll write it as y, or I'll write it as y equals the slope of negative 3.176 times x minus 6 plus, because remember it's minus, it's minus the point slope form. This would be a y minus that number. So I'll just move it over here and write it as plus 77.806. And that's what I would write in. I mean, because they aren't asking us to do any kind of prediction with it. So I don't really need to clean it up. So let me come over here and see if I can't. I always, when I do these math videos, I always like to make sure that I can get it right. If I'm expecting you to get it right, I should be able to get it right. I'm going to try that. And then I'm sure they wrote it in point slope form. Oh, they didn't. Look at that. Okay. See how it's exactly the same kind of thing. So I'm going to write it in. They did write it in point slope form. I'm surprised. I'm glad I picked this problem. So y equals negative 3.1. So I'm typing in 3.176 times x minus 6 plus the 77.806. Now let's see if, whoops, 70, I did division, 0.806. Let's see if it likes what I got. I gave it. You see, I've got the right answer. It's just a matter that it didn't like the rounding. What did I write? 806, 806. What do they have? 8061. Well, let's try 124 decimal. Let's see if it likes that. 0.124. Oh, did I write equals? That's what it didn't like. Oh. There we go. Didn't like my equal sign. I don't know why I wrote equals. All right, so that's how you do it. Okay, it's just this linearization. We're not asking to predict for it.